Alright, so I'm going to show you how to work some binomial probabilities in Minitab. So the menu for to calculate probabilities is right here. It's probability. So I've got a question over here that we can work on a little bit, and I'll show you how to manipulate and move around with this menu. In the probability menu, there's two options, really three options, but there's two popular ones. One's called a CDF, a cumulative distribution function. And the other one's called a PDF, a probability density or also distribution function. And this is a reverse procedure, and this graphs different probability distributions on a plot. But I'm going to show you how to use this menu here. This is the PDF menu, and the second one, the CDF menu. So let's take a look at this question here. It says, let x be a discrete random variable representing the number of tails that appear on 10 tosses of a fair coin. So the reason why this is binomial is because, you're playing the game 10 times. You're chucking the coin 10 times, and the number of tails that appear is a random variable. You don't know what's going to happen until it happens. So for this, the n, the number of trials, is 10. The p-value, which is the probability of getting a tail, it's the probability of a success, that's just a half. Or it'd probably just be easier to type 0.5. And of course the Q value, that'll also be 0.5. Remember, P and Q have to add up to the number 1. So we've got our values here for N, P, and Q. So now it says, what's the probability of getting exactly 5 tails? Alright, so that statement, we would write it like this: P parentheses x equals 5. Now in the scheme of things, if you drew a table where x was 0, 1, 2, 3, 4, 5, dot, 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 then this would be one of those possible outcomes. Alright, so obviously you could use the defining formula for this. So in our notes, I showed you the formula for the binomial distribution, and also in the textbook, you could use the actual formula. However, Minitab really simplifies this task by allowing you to give it the input parameters, that's the stuff right here in red, and tell it what value you wish it to work, and you have to also tell it, hey, what distribution you want, which in this case it's binomial, obviously, and then it'll crunch the probability for you. So in probability, so if you go over here, and we're going to calculate a probability density function. So that's a PDF. That works out one value. That's what we're doing here. One value, that the probability that the number of tails is exactly 5. So you click that menu. It opens up a menu and says, all right, what do you got? What are you giving me? I'm going to give you a single value. There's other options here, a whole column, and I'll show you how to do that as well. But a single value. And what's the value? All right, well, I want you to work out 5 for me. So give me the value of 5. Now it says, what distribution is it? Well, you see, normal is the standard. That's what's always pre-selected. But we're working in the binomial distribution, so you select binomial. On the full version of Minitab, it's got every distribution imaginable. Unfortunately, the one that's not here, which I wish was the geometric. It's not here though, so that's why we've got to work those things by hand. But you choose binomial here. And then it says, okay, the number of trials and the event probability. All right, well, number of trials, that's the n, which was 10. And the event probability, it's the event we're talking about. That's, getting tails, and that's a 0.5. All right, so, and then it asks you how you want your output. This output here is fine. Display a table of probability density values. It's going to give you, it's going to give you the output right here in this, what they call the session window, the output window. So again, we want a single value. The probability x is 5. We're using the binomial distribution with this 10 tries, and the probability of winning is 0.5, which is exactly what this is asking. So you say OK. And here you go. So this is one entry of the entire table. Remember, this entry for x would really start at 0, 1, 2, 3, 4, 5, dot, dot, dot. So as you can see, that probability is 0.2461 approximately to 4 decimal places. All right, let's look at the second one. The probability x is 2. P parentheses x equals 2. So that's what that would look like. Same deal. Probability, probability density function, single value, 2. The only thing I wish it would remember what we did last, kind of doesn't, which is kind of annoying. Again, binomial, 10 trials, a half is the probability of winning on any one of those 10 trials. What's the chances I win twice is what this is saying. So you say okay. And there it is again. So very straightforward type of thing. I guess at this point it would be nice just to see all of them. You know, in other words, there's 10 tries. You know, when you play 10 times, you might win all 10 times. Very unlikely, but you may. As a matter of fact, you may win no times. You could toss a coin 10 times and not get any tails. Again, very unlikely. But a way you could do this and work them all out would be to say, here's x, and type these values in. 0, 1, 2, 3. Name this column P of x. So this is everything that can possibly happen. Now, you know, by the way, we've worked 2 of these already. We worked this one right here, this P of x value. We have it, 0.0439 approximately. And we also worked this one, I believe it was about 25%, whatever it was. But you could tell Minitab, listen, go to this table right here, grab these x's, and work out the probability for every one of these events. So in which case you'll do probability density function. Not a single value, it's a column of values. And it says choose a column. Alright, well, x. It's binomial. Number of trials, 10. Event probability, 0.5. Alright, so show me a table. Everything's set here. So now the only difference is I'm selecting a column. And as you can see, it works out every one of those values that I selected here. There's another option in there that I could have asked it to dump the outputs in here, and it would have taken care of that for me. But as you can see, there's that one that we worked before, and before this one, you know, this one here. You see the navigator on the left here shows you all the things we've done. So probability density function at a 5, you know, that was the 0.2461 number. That's this one right here, 2461. And the probability density function at 2, 0439. There's right there, 0439. And you know, this kind of speeds things up for you. Like, you know, when you're looking at part C here, what's the probability of getting exactly 7 tails? All right, now you just read it from the table, 0.1172. Create the probability distribution of x, this part D here. Okay, that's what this thing is right here. That's the entire probability distribution. This is everything that can possibly happen. When you play this game 10 times and chuck that coin, you're either going to get no tails or 10 tails or something in between. If we add all of those P of x values right there, you'll get the number 1. Letter E, what's the probability of getting at most 2 tails? Well, at most 2 tails. Mathematically, we would write that as the probability that x is less than or equal to 2. Well, to put the less than or equal to symbol, I'll just fake it. Less than or equal to 2. I could go searching in the symbol browser for the symbol less than or equal to, but this will suffice. Now think about that. Less than or equal to 2, what that means. That's the same thing as saying the probability of getting a 2 or getting a 1 or getting none. So if you want to find the probability of getting at most 2 tails, that would be found by finding the probability of 2 tails, the probability of 1 tail, and the probability of 0 tails, and then adding those 3 scenarios together. Well, those numbers have already been worked out because I worked out every possible value here. So I could take 0's answer right here, 1's answer, and 2's answer, take those first 3 probabilities, add them together, and that will get you that answer right there. Alright, that's one way to do it for this part E. There's actually, believe it or not, a faster way to work this statement, the probability of being less than or equal to 2. And that's in the probability menu what this cumulative distribution function is. See, what the word cumulative means, it means from the beginning. So instead of working out these probabilities individually and adding them, instead you can take the cumulative distribution, give it one input value, say for example a 2. So give the cumulative distribution function a 2, and not only does it work 2, but it works 2 in everything before it. So 2 and backwards, in other words, cumulative from the beginning. So for instance, if you were to give it a 7, it would give you all the values from 0 all the way up to 7, and it sums them for you. So to show you how to use that menu, you select cumulative distribution function, form of input, yeah, single value. What's the value? 2. What's the distribution? Binomial. Number of trials 10, and the probability is a half. So you say OK, and notice what the value says here. When x is a 2, the probability that x is less than or equal to that x, in other words, the probability of being less than or equal to 2, 0.054687. Now, where does this come from, that number? Well, if you go back to the probability table and take these three probabilities right here, for 0, 1, and 2, and add them up, you will get this number here. So this cumulative probability function here is a way of working chunks of the table at once. Now, it only works backwards because it's cumulative. So think about it for a second. If you want, for instance, 3 and forward, well, there's no feature in the calculator here. I'm sorry, in the Minitab software. It doesn't give you the feature of going forward. It only gives you one value or a chunk of values backward. So if you want to work out a chunk of values forward, like for instance, from 3 forward to 10, well then think about it. Remember, all of these probabilities add to the number 1, and I know how to work 2 and backward. So if you think about it, everything which is 1, subtract off 2 and backward, would get you 3 and forward. So that helps you work probabilities that say at least, because the phrase at least a number means that number and higher. So for example, look at letter F here. What is the probability of getting at least 2 tails? All right, well, that would be the same thing as saying 2 tails, 3 tails, 4 tails, ... all the way up to 10 tails. Now, obviously, we could just add these probabilities together here, from 2 straight down to 10. That would take a while. Since all of these probabilities add to 1, we could take 1 and subtract off 0 and 1's probability. All right, that's a lot easier. So, the probability that x is greater than or equal to 2 would be found by taking 1 and subtracting off the probability of 0 plus the probability of 1. So give that some thought for a second. I want to be 2 and higher, but I don't have a feature to work that for me in the calculator. So I'll be a little bit clever about it. Instead of working 2 and forward, because that's going to take me some time. That's a bunch of probabilities right there to work. I could only work these 2 probabilities right here and subtract that answer from 1. So if you want to be 2 and forward, take everything which is 1 and subtract off 1 and backward. That's how you should think of this. Now, obviously, what about this little piece right here? I'll highlight it in a different color right here. The statement in blue, the probability of 0 and the probability of 1. Well, that's the same thing as saying the probability of being at most 1. So the computer will work that for you. You say, go over here, cumulative distribution, single value, yep, give it a 1. Make sure it's binomial. 10 trials, probability is 0.5. So when you give the cumulative probability a 1, it's not just going to work out 1. It's going to work out 1 and none. So you say, okay, it works out that value for you. The probability that x is less than or equal to 1, so there it is. You would take that result, subtract it away from the number 1 right here, and there you have it. So that thing in blue right there is this result right here. So you can see using the features here in the probability menu for cumulative distribution and probability density function, it really simplifies using rather than using the formulas. The defining formula for binomial is pretty difficult. And of course, the mean and standard deviation for the binomial, that's pretty easy. So remember, the mean, it's just formulas here. So the mean is equal to n times p. Make this bigger so we can see it. So that's just 10 times 0.5. Now, I mean, let's be honest. If you chuck a coin 10 times, how many tails would you expect to get? Remember, the mean is called the expected value, the long-term expectation. If you chuck a fair coin 10 times, on average, you should expect to get 5 heads and 5 tails. That's just the game. So, obviously, 10 times a half is 5. And then the standard deviation, well, first work the variance. That's equal to n times p times q. Alright, so that's equal to 10 times 0.5 times 0.5. Alright, I can't do that in my head. Minitab doesn't really, this version of Minitab doesn't really have a calculator set up for you. So that's why I told you, you always need to have a hand calculator, available to you. So this is 10 times 0.5 times 0.5. So there's the variance, 2.5. Now, it doesn't ask you to find the variance. It asks you to find the standard deviation. But remember, to find the standard deviation, you need the variance first. So the standard deviation is equal to the square root of the variance. So I don't have a symbol for square root to type it in Microsoft Word. But it's radical 2.5. So you go over your calculator, get the square root of 2.5. And it's about 1.58. So there you have it. Standard deviation is 1.58. So again, you'll need a hand calculator every once in a while because that hand calculator is not available in Minitab Express. So what this video is really trying to show you is that using Minitab Express's probability menu, it really speeds up calculations of probabilities, especially for letters E and F when you're doing chunks of the table, for at most and at least. Because remember, every probability requires that messy formula, NCR times P to the R times Q to the N minus R. And it takes a long time to work those probabilities by hand. Okay, as always, if you have any questions, shoot me an email.